Students, now this will be the next example for reduction formula. I'm just going to finish this one, then set you the exercise to do, and in the next lesson we're going to do some harder questions on reduction formula. But after these two examples, that should be enough for you to get started on the exercise and do the questions. Okay, so here's our question. We've got the integral formula In is equal to 0 to pi 2 cos the nth cos of x dx n equals 0 from 1 to 3, 0, 1, 2, 3, etc. We're going to show that this is true. Okay, so let's start off with the first part before we get to the second part. So let's have a look at this one. Well, first of all, we're going to write down the integral, and you'll notice that there is only one function here. Now, integration by parts requires two functions. So what we're going to do is we're going to split this up into cos x and cos n minus 1x dx. Okay? Now the product of those two functions is equal to this function here. Now we have two functions. Now we can use integration by parts. Okay? Now, why do we do it that way? Well, that gives us an n minus 1, and you'll notice in the expression here we do have an n minus 1 as well. So that's a good start. Okay, now, think about your formula. Integrate the first, leave the second, integrate the first, derive the second. So you've got to think of which one you're going to integrate out of these two. So we're going to call this, this is my function f of x, and this is my function g of x. Okay, so I'm going to integrate this one, and remember it's a reduction formula. Okay, so if I choose to derive this second function, that means I'm reducing the power. So that's the formula, that's the term that I want to reduce the power of, and that's also quite easy to integrate. Okay, so let's have a look. Right, let's just get rid of this. Come up here. Okay, so that's going to be, now, what's the integral of cosine of x? That is sine x. Okay, so we're going to integrate the first, leave the second. This is, don't forget, this is equal to In. Okay. Minus the integral from 0 to pi to integrate the first and derive the second. So it's going to give me n minus 1 cosine. Take 1 from the power. Right, now, don't forget we've got to use the chain rule here. So you're going to have to find the derivative of cosine of x, which is minus sine x. Alright, and then we've got the dx on the end. Okay? Alright, so we can tighten it up a little bit. Now we know that the sine of pi and 2 is 0. Okay? And the sine of 0 is, no, sine of pi and 2 is not 0. What I'm saying, sine of 0 is 0. So we're going to get, but we know the cosine of pi and 2 is 0. So if you put pi and 2 in there, you're going to get sine pi on 2. Cosine n minus 1 of pi on 2. Okay? Now that's going to be 0. Take away sine of 0. Cosine n minus 1 of 0. Okay. So all of this is going to go to 0. So I'm actually just going to, just for simplicity's sake, put a 0 there. Alright, that's all gone. And then I've got to simplify this a little bit, don't I? So now that minus sign there is going to become a plus with this one, and I'll take the n minus 1 out the front as well. Okay, I'll put that in brackets. 0, that should be pi on 2, not pi. Pi on 2. Okay, so that is sine x, and then we have cosine n minus 2x, but don't forget sine x and sine x combined to give us sine squared x dx. Okay? and the dx on the end. Alright, so there's our expression. Now, what are we going to do next? Well, we've kicked in minus 1 there, 0 to pi on 2. Now, we can combine the sine squared with the cos term by changing sine squared to 1 minus cos squared. So you're going to get 1 minus cos squared x, and then cosine n minus 2x dx. Okay, so let's work that through. N minus 1, integral from 0 to pi on 2. That's going to be cosine n minus 2x dx. No, not dx, too quick. Minus, now adding the powers together, you're going to get cosine nx dx. Okay. Alright, so our next step then, n minus 1. Now we're going to apply this as a separate integral. So we're going to take out 0 to pi on 2, cosine actually we'll leave that there. I'm actually just going to keep that as n minus 2x dx. Here we go. And I'll put n minus 1 a little bit closer. Okay. Then minus n minus 1, integral from 0 to pi on 2, and that'll be cosine nx dx. And that's all equal to in. Okay. Now, what's the advantage of this is that this expression here, okay, and this expression here can be replaced. Okay, so, well, let's think about this. What's this one? Okay, this guy here is just in. Okay, and this one here, right, that's just going to be in minus 2. So n minus 2. So that means I can write this down as in equals n minus 1 times in minus 2 minus n minus 1 times by in. Okay. Now, from there I could expand the brackets. Okay. Or I can put everything onto one side for the in, which I might do. So I'll go in plus n minus 1 times in, and that is equal to n minus 1 n minus 2. Now here I can take out in as a common factor. It'll be 1 plus n minus 1 equals n minus 1 n minus 2. Alright, so that's going to give me n equals n minus 1 n minus 2, and then n equals n minus 1, n minus 1 on n minus 2. And that is what we had to show. That's all good. Alright, so no need for those brackets there. That's all done. Alright, so that's part A. Now part B is evaluate these two integrals using our reduction formula. So let's do that. So make sure you copied all that down. And let's have a look at part B. Part B. Let's have a look. Alright, so part B, we have, okay, so solution, part B. Okay, now this here is I4, isn't it? And this here is I5. So let's do that. We're going to put I4 equals. Okay, we've got our formula here. I4 is 4 minus 1, which is 3/4 times by I2. Alright? Now, we can simplify that further. I4 equals 3/4 times, now what's I2? I2 is 2 minus 1, which is 1. Okay, over 2 times I0. Okay, now let's think about what's I0 here. I0 is equal to the integral from 0 to pi on 2. Now, that's just going to be 1 dx, isn't it? Yeah? So that equals to x from 0 to pi on 2, which is just equal to pi on 2. Okay? So then I4 will be, now 3/4 times a half, you're going to get 3/8 there. 3/8 times pi on 2, which is 3 pi on 16. Okay? Now, let's look at I5. Let's rub this out. Alright, I5. Now, I5 is equal to, so using this formula here, this recurrence formula, so it's 4/5 times I3. Okay? And then that's equal to 4/5 times, now I3 will be 3 minus 1 is 2, 2/3 times I1. Okay, now we're going to stop there because we can't keep on subtracting here. We're going to run into negative i's here, so that's not going to be good. So I1 is equal to the integral of cos x, 0 to pi on 2 dx. Okay, so sin x, 0 to pi on 2, and that's going to give me sine of pi on 2 minus sine of 0, and sine of pi on 2 is just 1. So that's going to give me, so I5 is what I had to find, so I5, which is here, there's I5, it's going to be 8 on 15 times I1. I1 is just 1, so you're going to get 8 on 15 is I5. Okay, so make sure you copy all that down. We're going to do some harder examples, but you can now, you've got now enough information to do 605 from the textbook. Now, you may have already started doing that because you didn't want to wait for me, but that's the set work. Make sure it's all done. And in the next lesson, we'll be looking at some harder examples of reduction formula in this topic. Okay, the ones I've done for you so far are fairly straightforward, but there are some harder ones we're going to look at.